You've driven past hundreds of tanker trucks, probably thousands, and you never once asked why they look like that. Why is the tank round? Why not a rectangle? Rectangles stack, rectangles fit in warehouses, rectangles make sense on every other truck on the road. Why not a cube? Cubes actually hold more volume for the same amount of material. Why does every tanker in every country, from every company across every decade use the exact same shape? Is it cheaper, stronger, safer? And why does the answer also explain your coffee thermos, your beer keg, your scuba tank, the plane you flew in last summer, and the batteries sitting in your TV remote right now? A tanker truck is, at its most basic, a container on wheels. That sounds boring. But here's what's actually happening every time one of those silver cylinders rolls past you on the highway. It's moving up to 11,000 gallons of liquid at 70 miles per hour. 1 gallon of diesel weighs about 7 pounds. Multiply that by 11,000 and you've got roughly 77,000 pounds of liquid that is very much alive inside that shell. Sloshing, shifting, surging with every turn, every lane change, every hard brake. That's the weight of about 25 full-grown elephants, all moving independently inside a metal shell on a highway. That liquid wants to tip the truck over. The shape of the tank is the truck's answer to that problem. And round wins every time. But why does round win? Here's what most people assume. The tank is round because that's how it's always been done, or because a round shape holds more liquid. Neither of those is the real reason. And here's the part that should make you feel a little tricked. A rectangular tank actually holds more volume for the same amount of metal. If the only goal were to carry as much liquid as possible, engineers would have switched to rectangular tanks a long time ago. They're easier to weld, easier to stack, then easier to load onto a frame. But they didn't switch, and that's the tell. The shape isn't about holding more. It's about surviving the job of holding anything at all. When liquid pushes on a wall, it pushes in all directions equally. That's just how pressure works. It doesn't pick a direction. It spreads out and pushes on everything it touches. Now imagine that pressure hitting a flat wall with sharp corners. The force doesn't spread out evenly across the whole surface. It stacks up hardest at the weakest points, which are the edges and corners. Those spots carry way more stress than the flat middle section. Under enough load or just enough time, that's exactly where things crack and fail. A curved wall changes everything. Pressure hits the curve and gets sent smoothly around the surface, spreading the load equally across every inch with no corner to concentrate on and no weak point to attack. Think about squeezing a pillow by pinching its corners hard versus wrapping both arms around it in a full hug. The pinch tears the seams because all the force goes to one spot. The hug holds everything together because the force is shared across the whole surface. A cylinder is the hug, a box is the pinch. And because pressure is shared so evenly across a round shape, you actually need less metal to safely hold the same load. That means a round tank is not just stronger than a square one. It costs less steel to build. Same shape, 2 wins for the price of 1. But here's where it gets crazy. The pressure problem is only half the story. There's a second problem that the round shape solves, and this one is the one that actually flips trucks. When a tanker brakes hard, the liquid inside doesn't stop when the truck stops. It keeps moving forward because that's what physics demands. In a rectangular tank, now all that moving liquid hits the flat front wall at the exact same moment, like a full wave slamming into a cliff face all at once. That's a sudden, massive force hitting one flat spot. It pushes against the truck's braking, it throws weight forward, and on a curve it can tip the whole rig sideways. But in a cylinder, the curved wall redirects that surge. The liquid rolls up the curve and eases back down gradually. Like water in a bowl, you tilt slowly and then bring back level. The energy gets spread out over time instead of arriving all at once as one brutal impact. This is the part everyone misses. The round shape is a built-in slosh absorber. It means tanker trucks can brake faster and corner more safely, and the geometry of the shape is doing work that the driver and the brakes simply cannot do on their own. You're probably thinking all cylinders are the same, but actually, look closely next time, and you'll notice some tankers are perfectly round in cross-section, and some are slightly oval, wider than they are tall, like a flattened circle. That oval shape pushes the center of gravity lower to the ground, making the truck much harder to tip over on tight highway curves. Some engineers argue the pure circle is structurally superior under pressure. Others say the oval shape wins on real-world road stability. One theory holds that the oval is only worth it for trucks carrying very dense liquids like acids or fuel, where the weight is concentrated and tipping is a bigger risk. Both designs are in use around the world, and both are still fundamentally cylinders at heart. Now compare that to the big rectangular shipping containers you see stacked on cargo ships and freight trains. Those are square and rectangular because they carry solid cargo: boxes, machines, packaged goods, furniture. Solid stuff doesn't slosh. It doesn't surge into a wall when the train breaks. There's no moving pressure problem to solve, so the rectangular shape is perfectly fine. The shape of any container is always the answer to one specific question: what is actually happening inside it while it moves? This shape is not new. It wasn't invented for trucks or for factories or even for the industrial age. The story goes back much further than you'd expect. Long before tanker trucks existed, people were moving liquids in wooden barrels, and barrels are round for the exact same reason. The curved wooden staves spread pressure evenly around the whole structure so the barrel doesn't burst open. Ancient Romans used cylindrical barrels for wine transport across the empire. Sailors used them for drinking water and whale oil on ocean voyages that lasted months, in rough seas that tested every joint. The barrel may be humanity's oldest real pressure container, and it was already around thousands of years before anyone understood the physics of why. Then came the Industrial Revolution and steam boilers in the early 1800s. Early engineers built rectangular boilers because flat walls seemed simpler and cheaper to construct. But rectangular boilers kept exploding, always at the corners, always at the edges, always exactly where pressure naturally stacked up. After enough catastrophic failures and enough deaths, engineers switched to cylindrical boilers, and the explosions stopped. By the time the American oil industry began scaling up fast in the 1860s in the Pennsylvania oil fields, that lesson was fully learned and deeply remembered. The very first tank wagons built to move crude oil across those fields were cylindrical from day one. The tanker truck rolling past you on the freeway today is a direct descendant of those Pennsylvania oil wagons, which were themselves built on lessons that cost earlier engineers their lives. And now, here's the part that should embarrass you just a little. You have been surrounded by this exact same engineering logic your entire life and never once connected the dots. Beer kegs are round because they hold liquid under CO2 pressure, and a flat-walled keg would fail at the seams. Same pressure problem, just smaller and colder. Scuba tanks are perfect cylinders because they hold compressed air at up to 3,000 pounds per square inch. And no corner or edge could survive that for long without cracking. Fire extinguishers are cylinders for the same reason: extremely high pressure, a life safety job, and absolutely zero margin for a weak point. Your home propane tank is round because propane is stored under pressure, and a rectangular tank would start failing at its edges after just a few heating and cooling cycles. Now, AA and AAA batteries are cylinders because the chemical reaction happening inside creates outward pressure as it discharges, and the round shell handles that gradual expansion evenly without bulging or cracking. Rocket fuel tanks are cylindrical. Same physics as a tanker truck, just pointed vertically and traveling considerably faster. Submarines use a cylindrical hull, but with the pressure running the other direction. The ocean pushes in from the outside, trying to crush the sub, and the curved hull spreads that crushing force across the entire surface, so no single point gets overwhelmed. Aircraft fuselages are round in cross-section because the pressurized cabin air pushes outward against thin outside air at altitude, and that pressure difference across thousands of flights would tear apart any flat wall with corners. Grain silos are round because dry grain actually pushes outward on walls very similarly to how liquid does. It flows. It settles unevenly. It creates pressure. Your insulated coffee thermos is a cylinder for both structural strength and even heat distribution around the liquid inside. Even MRI machines use a cylindrical bore. The round shape helps manage the geometry of the powerful magnetic field. Everywhere you look, the same equation keeps showing up and reaching the same answer. Now, for the honest trade-off, because there is one. The round tank sitting on a flat rectangular truck frame leaves triangular gaps along both sides and underneath. Dead space that can't be used. A rectangular box would fill that frame edge to edge and carry more total volume in the same footprint. Engineers knew this cost going in and accepted it anyway. Structural safety and slosh control were simply worth more than the extra volume. Some modern chemical tankers try to close that gap by using several smaller cylinders built inside one outer shell, so the truck can carry multiple different liquids in separate compartments without any risk of mixing. It's a smart workaround. But look inside any one of those compartments and it's still a cylinder. The workaround is round too. It's round because everything else failed. That shape on the highway is not tradition or habit or aesthetic. It's the last shape standing after centuries of corners cracking, flat walls splitting, and boilers exploding. And it's been quietly running your life, from your beer to your batteries to your breakfast flight, the whole time.